Okay, so we're going to talk about even and odd functions. I have to talk louder. Sometimes it doesn't pick it up. Okay, so an even function. The quadratic function is an example of an even function. If you look at the quadratic function, one of our toolkit functions, it looks like that. And if you notice, if you were to fold along the y-axis, so that line, the y-axis, if you folded your graph, the points on the right would match up with the points on the left. And so when that happens, we say that this graph is symmetric about the y-axis. Even functions have that property. They're symmetric about the y-axis. Now, algebraically, we can test to see if something's an even function. We say f of x, when f of x is equal to f of the opposite of x, if that's true, then it's an even function. So let me show you what that means with this example. So say f of x equals x squared, the quadratic function, which I already told you it's even. Okay, so if I take and put in f opposite of x, f of the opposite of x, then that would be the opposite of x squared. But if you simplify this, that's just going to be x squared, right? Because a negative times negative is going to be positive, and so you get x squared. Notice that you come out with the same function that you started with. So f of x is equal to f inverse of x. That's the test to see if it's an even function. So yes, this is an even function. And we have other functions that are even also, not just the quadratic function. But that's the test. Okay, and when we talk about an even function, that's what we're talking about, that this will hold true, that this holds true, and the function's symmetric about the y-axis. Okay, now let's look at an odd function. So an example of an odd function is the cubic function. So, f of x equals x cubed, okay? Now, the symmetry here is a little bit different. Pretend like you're taking your paper, your graph, and you're folding it along the y-axis. So that would put like those points over here, but then you're folding it about the x-axis as well, and then those points would come down here and line up. So the points on the left, if you do two folds on the y-axis and the x-axis, the points on the right are going to match up with the points on the left. We say that then that this function is symmetric about the origin. Okay, so symmetric about the origin being the point 0, 0. You have to do two folds for that one, okay? Now, if you have an odd function, the test for it is f of the opposite of x is equal to the opposite of f of x. Okay, so let's take the function that we have here, and we'll go f of the opposite of x. That's going to equal, now, I'm cubing it, right? So it's negative x cubed, but that simplifies to just be the opposite of x cubed. Okay, so it's the opposite of f of x, the opposite of f of x. Okay, when that happens, then it's said to be an odd function. Now, there are going to be some examples in the upcoming videos.